Alright, so we're looking at small neural nets that map 2 dimensions to 2 dimensions. And we did this in the previous live stream. And the idea here is that this is like input layer, first layer, second layer, third layer, fourth layer. And it's the neural net is trying to fit a training set mapping two-dimensional points to two-dimensional points that's randomly chosen, and also I don't have it visualized presently. But this last layer is a neural net with, I think, two layers. So there's two separate neural nets here. And we're training the small neural net to try to fit, or mimic the 4-layer neural net. And because we're just, I guess, trying to at least visually kind of understand, I guess, like representational differences. As you add more layers, you get more like presumably representational capacity. Like there's mappings, there's presumably mappings from R2 to R2 that a 4-layer neural net can represent that a 2-layer neural net cannot represent. Although, I mean, it appears to be the 2-layer neural net can certainly get close. I think maybe if we let's add more layers to the big neural net, and just say 6 layers. And what was the other thing I was going to do? Oh, so we have like a random training set just to force the large neural net to kind of like maybe more fully explore the space of like transformations that it's capable of representing. So this is the output of, these are all the internal layers, and this is the last layer of the large neural net. And then we just have the last layer of the 2-layer neural net visualized here. And, it's like, yeah, there's a visual difference. Also, the thing to be clear on is that the 2-layer neural net is being trained on like the full output of this layer, not just the training set. Although that would also be an interesting thing to look at. I could probably look at that quickly. Like what I wanted to do in this video was talk about the griddiness of each transform, because like this layer still pretty much looks like the grid, right? It's just, so I mean, like all the relative like positions are maintained, and it kind of looks like that holds. So yeah, we were just going to add, I guess, like another way of visualizing a layer, or like the two-dimensional like transformation implemented by a layer, which would be like the griddiness. So I guess I'll do those two things. So like I'll quickly, instead of training the small neural net on the entire output of the large neural net, we'll train it just on the same training set. I should be able to like implement that very quickly. Yeah, so like this is a small neural net and it has 2 layers. So I think, yeah. So we're just going to like completely comment that out and then fit the small neural net on the same training set as the large neural net. Okay. All right. So we're now, I mean, I guess like what that would do is kind of like highlight the differences like in the priors. Yeah, like unfortunately I don't have the training set like actually visualized, so I don't know like how well it's mapping or like how well it's converging. But clearly the small neural net is like doing weird stuff that the large neural net is not doing. So I think I might have to actually visualize the training set. Right, I mean like this kind of curve is definitely not something like a 2-layer neural net can implement, like represent. But I mean, you can kind of see like you want to say something like the 2-layer neural net, the transform. You know, it more resembles the starting grid, like the you know, whereas like the 6-layer neural nets can, I don't know, throw points like into corners more and get weird kind of like concentrations. So yeah, so we're going to try to visualize griddiness, and so the idea of I came up with for visualizing that is we're going to iterate over every point in the grid. This is going to be an n-cubed operation, but we're going to iterate over every point, and actually you might be able to do it betterly. No, it doesn't matter. So we're just going to iterate over every point in the grid, and then for each point we're going to iterate over its row and its column. And so if we're going like to the right, the x value, you know, needs to be greater than the x value of our point, right? So like, so every time that is not true, like we'll count that as like a violation of like the grid property. And so like for every point we will count the number of violations, and then we'll just visualize that as like a 2-dimensional heat map. and I think we'll like directly overlay it on the canvas for the layer. And so, you know, it seems kind of like there will be a correlation between like the number of layers, and because again, like a one layer neural net, right? I mean, this, to me, this looks like they're like every row is still in order, and every column is still in order. So like it's there's 0 grid violations. So that may be like one way of like characterizing the kind of like difference in representational power between like a shallow neural net and a more multi-layer neural net is kind of like the because it'll have more grid violations perhaps. So yeah, we're just going to like try to implement that, and I guess we'll just like implement it directly in the draw thing. I was also going to do something where like yeah, I'll do that later, whatever. Okay, so we're gonna do griddiness. So we want it to be in draw layer, and I should probably kill this so it doesn't kill my computer. Yeah. Oh, well actually I could have just hit that. That's fine. Okay, so so we're just gonna do like for every point in the grid, check all. Also, you could just do every point. Yeah, but we're just not going to do that because that would be quadratic, and we're doing cubic. I mean, it doesn't matter because we have like 1,000 points, but well, no, we have 100 points, but I mean, 100 power 4 is like a big number, isn't it? Like you would add 4 zeros, so you'd have 6 zeros, I think, if I understand my exponents correctly. So if you have 6 zeros, that's like 1,000,000. Yeah, we don't want to do 1,000,000. We're gonna, well, we're gonna do 100,000 instead of 1,000,000. Okay, so check all points in the same row and same column. And determine if if they're closer to each other. Yeah, I mean that's kind of a thing you could do. Like I don't know how to express it. Like determine if like they maintain the grid relation under the transform represented by the layer. like, e.g. in a row, points to the right of a point of the point should maintain a larger x value than the point to the left. Yeah. Okay. So anyway, we're gonna loop over so I need like a two-dimensional grid to keep track of the number of violations. Yeah. So grid violations, and then so the grid is actually oh yeah, grid array. Yes, so the thing is that we turn the grid into, I believe this is like effectively a list of two-dimensional points. I think that's fine though. I mean, I think you just yeah, let me make sure this is oh yeah. Okay, so grid.shape is 100 by 2. And so I think what it's doing is it's effectively putting each row back to back. So so I think we'll iterate like ij. It's just you have to like, you can't directly index to figure out the output point. But I think that's okay. Okay, so yeah, number of ticks, that's fine. J, number of ticks, that's fine. See, like grid.get is not a actual function. But also, if we have a new row, we have to push. Yeah. Okay, and then so I'm just gonna close that, and then so yeah, so like the current point is ij, and then we have to like loop through like the left neighbors and the right neighbors and the up neighbors and the down neighbors. I feel like there's a more like leet codey way of doing this. Like you could just process a single row all at once. But you know, this isn't leet code. So like, this is gonna be annoying. So like left neighbors, right neighbors, top neighbors, bottom neighbors. Yeah. So, left neighbors, if j is greater than 0, oh, you know what? Why don't we just, like, reshape? That way we can just directly index. That's such a better idea. That is such a better idea. Okay. So I'm just gonna reshape the actual output, for... Yeah, this is the data. Like, this is the output. And, so I'm going to not array sync it. Array sync it down here. And then just do... I mean, everything should still work, right? Everything still works? Yeah. Totally still does. So, so then we're going to say data equals tf.reshape data. Yes, exactly. Dot array sync. And then we can just directly do neighbor stuff. Although, like, you still have to do left and right, so that was kind of stupid to delete that, but that's fine. That's fine. Left neighbors. Right neighbors. Top neighbors. Bottom neighbors. Okay. So J is the column, I guess. Yeah. Yeah. Well, okay, so like violation count 0. Can't you just directly do like a loop? You can just say for like for left neighbor equals j minus 1, left neighbor is greater than or equal to 0. Because doesn't that automatically handle the boundary condition, like if you're past 0? I believe it does. I believe it does. So then we're saying if data I is greater, we're gonna, whoops, no, that was right, come back. Yeah, but we want it to be greater than or equal to, because that also violates the boundary condition, or the grid condition. Violation count plus plus. Perfect. And that's all for that. Yeah, okay. So then the same thing for the right neighbors. It should fill it out exactly, or like immediately. Yep, this is all good. This is all good. This is all good. Okay, top neighbors. Top so top neighbors, yeah, if the y value, whoops. Okay, bottom neighbors. Yeah, yeah. Like, what? Oh, is that already closed? No? What the heck? Okay, so then we say grid violations for the current row, push violation count. Yes. Okay, so that computes everything. And then we have to visualize it. So can I just do like a pixel per value? That might be too small, but it makes it into a tensor. No, we don't want to make it into a tensor. Draw grid violations to the canvas and the bottom left. Whoa, it knew which corner. But is it going to know how to do it? That's already kind of wrong, I think. Fill rectangle. No, you need to change the color based on the... What is it doing? I don't know what it's doing. So, as a heat map, does that help? HSL. Sure. I do not understand that at all, but that's fine. Grid violations times 100. Yeah, I don't understand that, but so then fill rectangle J times canvas width canvas. Is that the whole thing? I don't think that's drawing it correctly, but we'll just see what that looks like. Oh, it broke. Size 200 must match the product of shape 10 by 10. What? It doesn't like my reshape. At 118, size 200, size 200. What? It's 100 by 2, 100 by 2, and it needs to be reshaped. Oh, 10 by 10 by 2. Right. LN is not defined at 126. Oh. Oh, shit. No, you can't say profanities. Very cool. I mean, that is absolutely not what it's supposed to do, but it undeniably looks very cool. Okay, so, okay, let's kill that console log. And, so I think, well, first of all, let's, get the shape right, or the location. So, like, what is the size of my canvases, by the way? Oh, it doesn't matter. Yeah, okay, so anyway, pixels. Okay, so we want, so we just want the, we want these to be 2. And we want the location to be, if this is the x, so just j times 2, I think. And then the I, we want it to be I times 2, but we have to go from canvas. Do I have a canvas? Yeah, canvas dot height minus 20 is the starting location, I think. Okay, so they now should be in the corner. Okay, cool. That's too small though. Can't see it. So make them 5 pixels. And then that needs to be 5 times 10. And then these need to be 5 and 5. Yes, yes. This is very cool. So the colors are still, like, not correct. So I'm gonna do a color palette, which yeah. Whoops. Yeah, no, that's. Does anybody still use that? You guys remember Go? I actually never used it, but I remember it. I remember people talking about it. They're like, "Hey, you guys use Go?" Okay, so we want this to be sequential, and well, I just want it to be like a heat map, you know? I don't actually know how to use this. So, can I make that like darker? Yeah. And number of colors. Sure, 9. I don't know how many, like what's the maximum number of grid violations you can have? It would be, because there's 10, so it'd be like 20. So yeah, we'll just say 20, I don't know. Okay, so then we'll put that in a palette type thingy. So let palette equal. Oh no, I want the one on the clipboard, not that. Okay, so we have like a cool palette, and then the color is going to be palette number of grid violations. Okay. So now, oh, dude. My problem is that, like, you know, this should have 0 grid violations. Because there's no grid violations. And yet, it's giving me a high count. Also, what is happening here? Okay, so like, this isn't working, but it looks very cool though. So that's, at the end of the day, that's really all that matters, is that it looks really cool. Okay, I want 7 pixels per thingy. Okay, so the, something wrong is happening. Something wrong is happening. Okay, let's console log data to make sure that looks the way I'm expecting it to look. Oh. Oh. Yeah, we're not indexing correctly because it's actually a 3. Okay. Yeah. So this needs to say the x value, or yeah. So that needs to be a 0. That needs to be a 1. I can't believe autopilot. No. They both need to be a 0. Can't believe Copilot misled me. It's misled me. Okay, so that's 0, 0, and then 1, 1, 1, 1, 1, 1, 1, 1. Okay, now we're cooking. Oh wait, is it that? Okay, do it one more time. Okay, it still doesn't seem correct. It's not correct, I mean, it's still not correct, but it looks very cool. Well, this is my problem. Okay, we're gonna make this bigger one more time. Everybody likes doing that. And it's still not right. Oh, because, oh my goodness. Wow. Yeah, we didn't switch the sign. That's like another problem. So the left neighbors, the current point should be greater, but the right neighbors, the current point should be less. And then top, yeah, I don't know how the mapping here works, but I'll just use the same thing. So, okay, so like this is saying this is completely, okay, I mean, this is very cool. I was not expecting this to look as cool as it looks, but we still have a problem, which is that I thought the 0 value was dark blue. And, okay, yeah, like what is the 0 value? So we're gonna pull that out, and I think I just like add a legend to visualize the palette in a new div, I guess, like just, well, in a new canvas, I guess. Yeah. 300 Well, it doesn't need to be that. I mean, okay, context. What are you doing? Ah, it doesn't understand. For let color of palette draw a rectangle, maybe? You know? Fill rectangle, yeah. Okay. That's good. Okay. So we should now have like a legend. Not. We don't have a legend. Why not? Why not? Why? So say palette dot length times 10, and then oh jeez, for palette length, palette I, fill rectangle. Okay. Okay, it's, I don't know why it's, so, okay, yeah, so like these have 0 violations, right? So like these are all effectively grids. Okay, but something bad is happening here. Yeah, it could be like, I guess like if you completely rotate the grid, like then you'll have full grid violations. That could be a thing. So, okay, so let's get rid of the legend again. Why is this not working? Twolayer. Data IJ. Violation count. Grid violations I, push violation count. IJ. Fill style. Console log grid violations. Nine violations. So we seem to be getting a lot of 9s. Yeah, I'm thinking I have the signs wrong. Inexplicably. Well, yeah, maybe for... I'm thinking these might go the other way. So that needs to be less than... That needs to be greater than or equal to... Twolayer 144. What is happening? It should all be good, guys. I think my computer melted. Cannot read 144. Also, these need to be... It is less than... It is greater than... Oh, less than or equal to number of ticks. No, that needs to be strictly... Oh, I changed the wrong thing, I see. Okay, wow. Yeah, it's about time to, Yeah, okay, wow. Jeez! Okay, I see what I did. Wow. Yeah, I changed the wrong... Okay, I should have changed this one. Wow. Okay, so that needs to be greater than 0, less than the number of ticks. This needs to be greater than 0. I got confused with the two lines. Yeah. That's why. Okay, so the left neighbors... Yeah, it's saying if it's greater than, it's a violation. This is saying if it's less than, it's a violation. And then I think we wanted to switch these. Okay. Yeah. No, it still doesn't seem correct. Like, this should be a dark blue. Like, it should start out dark blue. So we'll just switch that again. Why is it not... Okay, now it's dark blue. That's weird. But now it's saying, like, I mean... Okay, I guess I'll have to debug that. I mean, like... Unless... Am I using two palettes? No. It's starting out with like a high number of grid violations. Yeah, I'm gonna have to debug that.